All right, let's talk about the application of calculus. In the application of calculus, you will begin to understand that there is a part where the learner is expected to have known the measurements that were taught in grade 9, 10, and 11, that they have to now apply them into this real calculus. So there they have to remember the formulas of those two-dimensional objects and the three-dimensional objects as well, that they need to understand what is the total surface area of a three-dimensional plane that is given, or the volume of that 3D. So if the learner doesn't have that background, it's really going to be difficult to actually do this part in application of calculus. For example, here, if we look at this object very closely, you will realize that it is made of this portion, which is looks like a semicircle like thing, and this one which is like a semicircle like thing. So if we can combine them, we can form a circle, right? But we shall see what is this shape all about, because it could be the two-dimensional shape or a 3D for something that has its volume, right? So it's the statement that is going to tell us more about what we see. Let's do this question. We are having a satellite is to be constructed in a shape of a cylinder with a hemisphere at each end. So which means now this is a cylinder. As you can see, the cylinder is something that is like that. So something that you can pour water or anything that can be having a space in a cylinder that is having a base, right? So this is the cylinder-like thing which is found right in the middle of these two hemispheres that are found on each end. So this is the hemisphere that you have, this is another hemisphere that you have. So we can see now it's no longer a semicircle, instead it's the hemisphere. And the hemisphere, ladies and gentlemen, is just the half of the sphere. Hemi means half. So we are having a ball-like shape like that. A ball-like shape like that. That it's just like that. So this is the first hemisphere, this is the second hemisphere. Then if you combine them together, they form that complete sphere. So which means now we are having this hemisphere plus hemisphere is equal to the sphere on its own. So on that note, we can continue doing our work, because we have already found some tangible scenario about the object itself. The radius of the cylinder is r meters and its height is h meters. So this is what we can see. This is r meters and the height of the cylinder is h meters. The outer surface area of the satellite is to be coated with heat-resistant material, which is very expensive. Some of the information may not be effective in the questioning approach, but nonetheless, it has to be there. The volume of the satellite has to be pi over 6 cubic meters. So we are having this information at this time that we are going to be using. Fortunate enough, we are having a bunch of information or the formulas are on the side that may be related on the object that is given that we are going to be dealing with. So minus one problem on that. We don't have to crack our brain to think about what was the formula of the cylinder, what was the formula for calculating the volume of the sphere and stuff like that. Everything is given over there. So let's continue. We are having this one. So let's answer the question. Show that h is given by that expression. So we really need to know, okay, this h can be given that way. So the idea is to use the information that is provided to us. The information that we have so far is that the volume of the whole satellite is given by pi over 6. So the idea is to know now what is the volume of the whole satellite, beside being given the value of it, but what is its formula. Mind that there are two shapes that are being combined to form this object, which is this hemisphere and that hemisphere, that can form a sphere, which is the complete sphere, and also this cylindrical shape which is found between of these spheres, right? So we need to combine the volume of the sphere and the volume of the cylinder to form the volume of the complete satellite, which is equal to pi over 6. So now the volume of the satellite, yeah, let me just say the volume of the satellite is given by the volume of the sphere. There's nothing to think much, because this is the volume of the sphere, which is 4 over 3 pi r cubed, then plus the volume of the cylinder, which is this middle portion, which is the volume of the cylinder, ladies and gentlemen, is the area of the base times perpendicular height. Then the base of the cylinder is, of course, a circle. So the area of the circle is pi r squared, then times how high or how long is how high the cylinder is. So the height of the cylinder. Now, this is what we have. So remember now that the volume was provided. So we just need to substitute the volume that is provided to our formula. So V is equal to pi over 6, then which is equal to 4 over 3, then pi r cubed, then plus pi r squared h. So at this stage, you really need to find h as a subject of the formula. Well, of course, you can just take this one and write it on its side, h, then this is equal to, take this one to the other side, which is going to meet pi over 6 over there, and it's going to change the sign because it's not in its side. So this is what we have. Then dividing by pi r squared both sides, which means divided by pi r squared, then divided by this whole thing divided by pi r squared, then you will end up having pi this side, then this is going to be equal to, of course, it has to be equal to what you are showing. So let's just not waste time trying to prove our algebra there. This is not time for that. So our h is going to be that. Then moving to the next question, because now we have shown that h is equal to that, which is what was required. So the next question says, hence, which means you have to use what you found on this question. You have to use this h to actually answer this question. Hence, show that the outer surface area of the satellite can be given as S, which is in that expression. So now you need to be mindful or remember the surface area of these two shapes, which is this shape, the sphere, and the cylinder on its own, right? So, but there's something weird about the cylinder, because this cylinder, if we are having the cylinder like this, and this cylinder is open on its end, right? It's open because there is a hemisphere that is enclosing it on each end. So if you are to pour water, if you can open a hole here, pour water here, this water will go through all this up to this end, because the cylinder, which is in the middle of these two hemispheres, is open in each end. So we basically don't have the lids of this cylinder. So that is why now the surface area of this cylinder is gonna be only the surface area of the lateral side, which is the lateral side, which is this one, not necessarily the areas of what of the circles that used to be found in each end of this Gunuluza thing, so which is a normal cylinder. But now we can see the scenario is changing everything. But before that, we know that the surface area of what of the cylinder is what is 2 pi r squared plus 2 pi r h. But now, since I've already explained that, we really don't need this part because it is catered for by the lead, which is what we shall these two hemispheres. So we basically have this just 2 pi RH, which is the side face of the cylinder. So that means now the total surface area of this whole satellite, which is the total surface area of the whole satellite, is the surface area of the sphere, which is total surface area of the sphere is given by 4 pi r squared. So you just need to think of about 4 circles combined to form a sphere, which may not make the literal sense, but just think about them, because we have 4 pi r squared, which means we have 4 circles to form a sphere. And let's just think it that way. So the total surface area of the whole satellite is 4 pi r squared, which is the area of the sphere, plus the area of the cylinder without the lid, right, which is 2 pi r h. So having this one, we just need to do the substitution, and the substitution that we're going to do is just the substitution from each side. So we have 4 pi r squared plus 2 pi r. Then our h was given by 1 over 6 r squared minus 4, yes, which is 1 over 6 r squared minus 4 over 3, then r. So this is our h having substituted in its place. So now we can just try and play around with the algebra, trying to simplify so that it gets into this stage. So on that note, we are having 4 pi r squared, then we can just multiply these whole things. Sit okay, this we have this, we have plus a 2 pi r over 6, this is plus over 6 r squared, then minus, then 2 times 4, which is 8 r, okay, pi r squared over 3. Then therefore we can just play around trying to add these two like terms, because they are, yes, of course, like terms. Then having them up, then they will be like terms, gonna be 4 pi r squared, then this plus that is gonna be 4 pi r squared over 3. Then this one, if we simplify this one, we'll get 1 over 3. Then here cancel that one, we will end up having just pi up there. So this is over r, because we are left with this r over there. So this is our surface area. We have shown it, which is it is equal to just that. So coming to the last question. The last question says, calculate the minimum outer surface area of the satellite. So the minimum, when you are given the minimum, this question is actually a random question that is used after you have proven that the surface area is this or the volume is this. You just need to be reminded of finding the derivative, and the derivative is equated to 0. So at minimum or maximum, you just need to know that the derivative of a function is equal to 0. Then you solve for what you are looking for, right? So this is what you just need to be reminded of. Now we are having this function now, right? we are having that function. So the function we have is surface area, which is equal to 4 over 3, then pi r squared, then plus we have pi. This question, this equation is not in a differentiable form, that we need now to take this r up there so that we no longer have the respected variable in the denominator, so that we can derive this kind of situation. So after that, we derive it because now it is differentiable. Now we have a surface area prime, which is the derivative of it. If you drop this one, you'll get 8 over 3, then pi r, then minus pi r to the power of negative 2 over 3. So we actually have this kind of thing. Then we know that the derivative must be equal to 0 at maximum, at maximum or at minimum. So that is why we take this 0. So we have 0 is equal to, then we have 8 over 3, then pi r, then minus pi divided by 3 squared. So it's very important to always change your negative exponents to positive exponents. Hence I've taken this one down back where it was, so that now it changes the sign to be positive 2. So on that note, we can just multiply by 3 r squared, because it seems to be the lowest common denominator, which is 3 r squared. So now if we multiply by 8 both sides, you will have 0 on the side, of course. Then therefore this side you will be having still 8 pi, then r cubed, then minus just pi. So if you take this pi to this side, you'll be having pi is equal to 8 pi, then r squared, no, not r squared, this is r cubed basically. Then therefore we say r cubed is going to be equal to 1 over 8, of course, because pi and pi, they are going to cancel each other. Then we are actually having r being equal to just 1 over 2. So having this one, I think we haven't answered the question, because we are looking for the minimum surface area, not the value of r at minimum. So which means now we are going to take this r that we have and substitute to our original surface area to actually find the surface area in its maximum, its minimum, I mean. So this means we are having 4 over 3, then pi, then we have 1 over 2 squared, then plus pi, then over 3 r. Yes, so this is what we have. Then our r is 1 over 2. Is 1 over 2. So when you press your calculator, sorry to have dirty work, but nonetheless I believe you still follow me. Then we have 4 over 3, then times pi times 1 over 2 all squared, then plus pi over 3 or 1,5. So the answer is just what you call the answer here. The answer here is just, okay, there's something that I did, which is the brackets are not supposed to be there, they're supposed to be here. So the answer is just pi, which is equivalent to 3,114 square units. So this is the minimum surface area, outer surface area of that object. I think you understood the whole process that I just undergone. And if you have any questions or anything that you really concerned about, you can just drop a comment, and anything that you really want the clarity on. But I think it's really self-explanatory, the presentation on its own. See you in the next one. Bye.